Professor Bob Young here, and in this instructional video we are going to work on solving exponential equations. So let's look at a property of logarithms first, since exponents and logarithms are inverses of each other, as we are finding out here. Let's take a look at if x is greater than 0, y is greater than 0, a is greater than 0, and a can't be 1, then the log base a of x equals the log base a of y if and only if x equals y. And also notice you can do this with natural logs, since we do have the same base number here. Now, what was the base number for natural logs in previous videos? Don't forget e here. So if you have the ln x equals ln y if and only if x equals y as well. So we're going to look at an exponential equation. 7 raised to the x power equals 12, and it says give the solution to the nearest thousandth. Now notice in the solution down here, the properties of exponents given in previous lessons cannot be used to solve this equation, because remember, in previous lessons we used to be able to get these base numbers the same. I mean, all the other exponential equations we've talked about, and I'll give you an example here. We had like ones like 5 to the 2x minus 1 power equals 125, and we could get a same base here on 125. We could say that was 5 to the third equals 5 to the 2x minus 1 power, and then we could set the powers equal and solve. But ladies and gentlemen, up here, I'm going to put a sad face. How are you going to get a same base out of the numbers 7 and 12? So while also go down the bottom here, it says while any appropriate base b can be used, the best practical base is base 10 or base e. Now we're going to choose the base e ln here on this example. So here's how we're going to attack this. Since exponents and logs we have found are inverses, we're going to attack the exponent by taking the natural log of both sides of the equation. Now remember, equations, as long as you do the same thing to both sides, fair game. Then we're going to use log rule number 3 here, going back to the log rules. I know you thought they were done, but they're never done. And we're going to take this variable on x, rewrite it in front. All right, now how useful was that log rule there? It helps us solve these more difficult exponential equations where you can't get the same base numbers. And then we just divide both sides by the ln of 7 here, which is just a number. It's e raised to what power gives you 7. And then on your calculator, putting it in, you should get about 1.277 rounded to the nearest thousandth. All right, now again, if you took that whole answer on your calculator before you rounded it and you used your answer key here, let's go back up top. If you said 7 caret raised to the answer, ANS, and hit equal, you could check it. You would get 12 back, exactly 12. All right. So now also there's a caution here. Let's put a caution flag up. Be careful when evaluating a quotient like the natural log of 12 divided by the natural log of 7 in the previous example. Do not confuse this with the quotient with the natural log of 12 over 7, which can be written as natural log 12 minus the natural log 7. So we cannot change the quotient of two logarithms to be the difference of logarithms. So notice down here on the bottom, these two creatures are not the same. Don't believe me? Check those numbers on your calculator. It will not work, and if it does, it's time to take it back and get a refund. All right, now on to more vicious type questions here. Oh, before I do go on, I wanted to point something out here on this previous example. Also on this one, you can see a lot of textbooks, or you might have instructors that would have taken the common log of both sides of this. I wanted to mention that. And you could have also then used the third log rule and just rewritten it like this. See, so if those base numbers are the same, you will get the same result. So you could have also divided by the log 12, common log 12 divided by common log 7. And since those base numbers are the same result. All right, now let's get on to that next example here. Now this one's really got some bite in it. This is like the toughest exponential equation that you may ever encounter. So once again, and you know, reason why this one's so much tougher is because you have a whole bunch of things in the exponents and they're on both sides of the equation. So anyhow, we're going to go ahead and take the natural log of both sides again. We're going to take these exponents and rewrite them in front using that third log rule, which allows us to do that. Oh, these log rules are so helpful here, and I'll put log rule number 3 there. Now notice here, you've got 2x minus 1 times the natural log of 3 on the left. So remember, the natural log of 3, this is just like some number out here. It's e raised to some power gives me 3. It's a nasty number, yes. I mean, if you did it on your calculator, but it's a number. And again, we're just going to go ahead, since it's a number, and we got something on the outside, we're going to distribute it. And here's what it looks like. It looks like 2x times ln3 would be written like this. Minus 1 times ln3, well, minus 1 times anything is itself. And we're going to do the same thing with the ln, or natural log, of 0.4 here. We're going to distribute that through both items here. And again, here's how it looks. X times ln4 plus 2 times ln4. So we are distributing here, ladies and gentlemen. Now, notice we're trying to solve this exponential equation for x. And once we distribute here, and notice in pretty blue, and I like, you know me, I like to use the colors and underline things, we have a common item here in both of these two terms. We can take an x out. And when we do that, it's factoring here. So we will factor the x out, and here's what's left. 2 times ln3 minus ln 0.4 equals, and all this over here is some giant nasty number over here. Let's put giant nasty number. That's the number symbol. Except I didn't put nasty. All right. So now to solve for x, we're just going to divide both sides by 2 ln3 minus ln 0.4. And that's what they did over here as well to get to this step. Now at this step right here, Young calls this a log jam. Or a natural log jam in this case. Now, you notice they use some powers of exponents in the next step here. You don't need to go here. You don't really need to go to this step. You can, from your calculator, take what's circled and put it in, but you're going to have to be very careful again. All right, so let's try that. We're going to put parentheses, we'll do it in green, 2 ln. Now, some calculators, when you hit ln, it automatically puts a little parentheses after the number. Some do, some don't, so watch out for that. So parentheses 2, natural log, 0.4 in parentheses, plus 3, close, divided by, okay, parentheses 2, natural log. Now, it may do the 3 in parentheses 2. It may not. Depends on your calculator. Minus 0.4, close, and hit enter. Now, they use some power properties and stuff. They kind of use the third log rule in that next step. Don't need to. And in the next graphic here, they even went, and once they did that, they simplified. But hopefully, if you did that way back, and I mean, they did a whole bunch of other stuff using log rules, you would get to about this answer. So you and your calculator must become one, rounded to this 1,000th place, negative 0.236. Did you get it? So also they wanted to emphasize that here is an exact answer for the problem, all right? And then when you use your calculator on it, you will get this approximate answer. But remember, this could be checked as well here, because this answer keeps going and going and going and going on your calculator. Now, to check this one, you would have to rewrite this equation. You'd have to say 3 to the 2x minus 1 power. Bring this 0.4 to the x plus 2 power over to the left part of the equation. How? Subtract it. So it'd be minus 0.4 to the x plus 2 power equals now 0. So we could rewrite this equation, and now we can use our answer key. So when you have, and this is how you check these on test and everything else, you have this big long answer. Now, of course, we rounded it to put what the problem specified, but if it's all there, then see, once you get your answer key, you can go ahead and here's how you check it. 3 caret, and then you would put parentheses, 2 times the answer, ANS, minus 1. So that's all raised to that power. Close parentheses. So again, parentheses important. Minus, and I'll put it under here, 0.4 caret raised to the answer plus 2 power, and then close parentheses and hit equal. See, so if you've got everything on one side of the equation, you can use that answer key, and it should check and give you 0. A lot of instructors won't show you how to check these creatures, but you can if you're careful with your calculators. More examples, you ask? More examples? Let's take an exponential equation with base e in it. All right? So what if we have e raised to the x squared power equals 200? So again, we're going to go ahead here on this example, and we're going to take the natural log of both sides of the equation. Now, there is some rule here that we need to look at. There is a rule on your logarithmic handout with natural logs, and it is this. What is the natural log of e raised to any power? We'll call it x. What is this equal to? Now, notice on a natural log, what base is down here? Well, there's really a little base e. So they're saying, and we can put a question mark here, they're saying if you do the clown face, e raised to what power gives us e to the x? And notice we have the same bases there. So the question mark would be x. So when you take the ln of e to any power here, when that ln hits e, since they are inverses, there's that word undoes again, and it spits out that power very nicely. So you get x squared equals the natural log of 200. And of course, to get that, you have to take the square root of both sides. So you get plus or minus the square root of the natural log of 200. And if you do that on your calculator, it should round to about plus or minus 2.302. Okay? And notice both positive and negative answers will check here, because if you put a positive in here and squared or a negative in here and squared, if you use your ANS key again, and you can, okay, you got this big long number here, positive or negative that, so usually you just check the positive side of it, and the negative will work too since you're squaring it. So hit E, caret, and they usually, well, I would put a parentheses on here or something, and then you could put that answer squared. So you can put caret 2 on that, and it should come out to be 200. All right, so this one has a double caret because you've got e raised to x raised to some power. I dig it. It just doesn't get any better than this. What's that? You want a more difficult e problem? Let me give you a vicious e problem. You know, Young, he likes lots of examples here. And I'm also going to put a little multiplication symbol in here because there's one missing. So I catch these things very quickly. All right. So here's the final example in this video, and then you can go and start pounding on these on your homework. E raised to the 2x plus 1 power times e to the negative 4x power equals 3 times e. So what we're going to use here is we're going to attack this with some power rules. So we're going to look at this one, and we're going to say, power rule number 1 says whenever you multiply same bases over here, you add the powers. So we're just going to take these exponents, 2x plus 1 plus negative 4x, add them together in the first step, and get e to the negative 2x plus 1 power equals 3e. Okay? Now, what do they do next? They look like over here it says divide both sides by e. All right? So if you do that, you're going to subtract the powers here. So let's go ahead and show this because they don't really show a good thing on this. And remember, if you're dividing by e, that's e to the first power. So we need to show these steps here better. Okay, e to the first power. So what you're doing here, and I'm going to go to my blue here, pretty blue, is whenever you divide same bases over here, you subtract the power. So you've got negative 2x plus 1 minus 1, subtracting the powers. The 1's go out, and you're left with e to the negative 2x equals 3. Because remember, e is just a number, so you can divide it by both sides. It's not like a variable or anything here, but now we're going to slap that ln on both sides of the equation, and we're going to also remember this rule here, that if you take the natural log of e to some power here, you're going to get that power. Okay, so when the ln hits this e here, notice in this case they actually pulled the negative 2x out, which I've seen students do too, using the third log rule, and they wrote it ln e here. But the ln of e, you should know, is 1. So this one's got all kinds of good stuff in it. So here we go. That will give us negative 2x ln e is 1 equals ln3. And they multiplied by negative a half here, but I think I would have just went ahead and divided both sides by negative 2. So put this in your calculator, the natural log of 3 divided by negative 2, and you should get about negative 0.549, which again would check if you wanted to check it. All right, so have some fun with these exponential equations, and remember that logs and natural logs will take out the exponents. So Professor Bob Young signing off till the next video.